So when we translate functions, especially rational functions, we do exactly the same thing we do with any function. So we're going to do a little bit of review here. Here is the graph of y is equal to x squared. And we could change that. If you had the graph of y is equal to x minus 3 squared plus 2, we know that the vertex for this, right, it's the vertex that we kind of follow. The vertex is going to be 3, 2. And if you remember, we had vertex form where the vertex is hk. So what is the opposite of what you have in here and plus that, right? So basically we would say that if we're going to graph this, the vertex has creeped to the right by 3 and then up by 2, right? And this is no different if you have a rational function, except there's a little extra meaning to it. The general rational function uses both the x-axis and the y-axis for its asymptotes, and the equation is y is equal to 1 over x. So if we have something like y is equal to 1 over x minus 3 plus 2, the whole graph would shift 3 units to the right. So the asymptote would shift 3 units to the right and 2 units north. And then everything is going to look exactly the same, right? So 3 to the right, 2 north. So generally, if you have something like this, 1 over x minus h plus k, so it's the same idea that we had for parabolas. Or vertical asymptote is going to be at x is equal to h, and our horizontal asymptote is going to be at y is equal to k. Now, the other way that you know this is because the bottom can't be equal to 0. So x can't be equal to 3. And if x can't be equal to 3, that's why we have a vertical asymptote there.